Hi, Sharan. How are you?
Fine, sir.
Right.
Good evening, sir.
Good evening, Lokesh. Right. Let's start now.
Sir,
Yeah, tell me.
sir, can you keep some test or something like that? Means like until now, whatever chapters we have done, like questions only sort of
Uh,
class.
yeah, tell me what you said.
Sir, like means can we have only like questions sort of class? Means from all the chapters we have done till now.
Okay. Okay. For today's class, you are asking,
Yes, sir.
right? Okay, Sharan. Let's discuss some questions then. Right. So that whatever we have discussed till now, it will get practiced.
Yes, sir.
Right.
Yes, sir.
Okay. Okay. So I will give you some questions. Okay. Now you also try to solve, and then we will also discuss that question. Okay. Those questions. Okay, so we discussed till now electrostatic part we have discussed. Okay, right? And electrostatic potential we have discussed, and the conductor and capacitor we have discussed, right? So these are the thing we have discussed. Actually, let's discuss some questions on those topic. Okay, so in the electrostatics, and then we will continue from here in the tomorrow's class. Okay, right?
Okay, sir.
Okay, so let's discuss now an example. Okay, in the question they have been, it has been given. Okay, two charged particles are there, and they are connected with what? An insulated string. Okay, strings are what? Insulator here. Okay, both the particle has same mass and the same charge given to us in the question. Right now they are in the air. Okay, and they are making what? Same theta theta angle with the vertical. Okay, now they are saying they are dipped in some other liquid. Okay, initially uh, the system is in what? This system is in air, or you can say that vacuum. Okay, now it is submerged in submerged in a liquid. Okay, in a liquid having density rho. Okay, liquid density how much given? Rho. And even after submerging, what happened? The angle theta they were making with vertical, na, that didn't change. Okay, without changing the angle theta, without changing angle theta. Okay, right. And the density of the particle is given as sigma. Density of these two charged particles is what? It is given as sigma. So now they are asking in the question, find dielectric constant. Okay, find dielectric constant of medium. Understood? Find the dielectric constant of the medium is how much? Initially, these two particles are in equilibrium, making how much angle? Theta angle with the vertical. Okay. Now, when they are submerged in a completely submerged completely in a liquid whose density is rho, still what happened? The angle between the angle made by the string with the vertical did not change. That remained still theta only. Okay. Density of liquid is rho given, density of particle sigma given. They are asking what is the dielectric constant of the medium in which it is submerged. Okay. Understood the question?
Yes, sir.
Please tell me. Understood the question? So tell me what will happen here. Try this one now. First, write the equilibrium condition initially. Okay, initially what forces will be acting on these particles? You can draw the free body diagram of any one of them.
And tension.
Right, tension will be acting, mg will be acting, and electrostatic
And
force.
electrostatic.
Right. And after submerging, what will happen? Tension will be there, mg will be there, electrostatic
Buoyancy
force
will
will be there, and one more force, the buoyancy force will
buoyancy force.
start acting. Okay, so please write the equation and check it how much it is coming, which force got changed, which did not change. How much is this coming? See, what we are going to do it in this question, we are going to solve the two cases. Okay, two case means what? First case, when this entire arrangement is given in the air or vacuum. Okay, so when we solve this question in the air or vacuum, and if I draw the free body diagram of this mass, I will find out three forces acting on that. Mg of object will be acting, and both are simple charges. Na? So electrostatic force will be repulsive in nature. Okay. So I am drawing the free body diagram of this one. Okay. And it is making some theta angle here. So this angle is also going to be theta. Now, if I take the component and then try to write the equilibrium condition, we will get T cos theta, and these two components will come T sin theta. If you write the equation, you will get it T sin theta equal to electrostatic force and T cos theta equal to mg, we will get it. And if we divide it, what will happen? Sin by cos tan theta will come electrostatic force by mg force, isn't it? This is the situation of this particle in equilibrium when this arrangement is kept in air. Now we are going to see that what will happen, what will change if this goes in the medium. Okay, in this medium. So in this medium, if I draw the free body diagram of same particle, can I say tension magnitude will change? Right? Earlier the tension in the string was T. Now let's say the tension is something T dash. Next, mg will change? No, mg will not change, isn't it? Next, can I say electrostatic force will change now? Please tell me. Electrostatic force is medium dependent quantity, isn't it? So
Yes, sir.
electrostatic force will change. Let's call it Fe dash. And one more force will be included in this free body diagram now is the buoyancy force. But as per the question, this string is still making how much angle? The same theta angle with the vertical. Now, if you take the component before writing the equilibrium condition, you will get it this component as t cos theta, and this component we got it as the t dash sine theta. Let's write the equation. So if I write the equation, t dash sine theta equal to new electrostatic force and t dash cos theta plus buoyancy force. Now that is balancing the mg. Just do little bit modification here. T dash cos theta will become how much? It will become equal to mg minus buoyancy force. Let's divide them one more time. Right? This equation t dash sine theta and t dash cos theta. If I divide it, I am getting tan theta now is new electrostatic force by mg minus buoyancy force. Understood? Case 1 tan theta and case 2 tan theta, now you see it. Both are tan theta only. I can compare them, isn't it? So I'm getting electrostatic force by mg, new electrostatic force by mg minus buoyancy force. Acha, tell me, what is this electrostatic force? Is this the electrostatic force in the vacuum?
Yes, free
Please tell me.
space.
And is this the electrostatic force in a medium?
Yes, sir.
And do you know what is that ratio called as? Electrostatic force acting on a charged particle in vacuum to the electrostatic force acting on a charged particle in the medium, that ratio is called as something mg by mg minus fb. That ratio is called as relative permittivity or dielectric constant. Relative permittivity and dielectric constant is same thing. Please tell me, understood? What is the permittivity, relative permittivity of this medium, this liquid medium? So
Sir,
relative
it's a medium by
permittivity of
vacuum, sir.
or Mhm. No.
Yes,
Check
sir.
it once. It is the net electrostatic force in vacuum to the net electrostatic force in medium, right? Let's see. If you remember, dielectric constant we have
Okay.
written
Yes, sir. Yes.
electrostatic force in vacuum by electrostatic force in medium. When you write in the vacuum, you will write it 1 by 4 pi epsilon naught q1 q2 by r square, and same pair of charges kept in a medium. So what it will become? Medium force, how much it will become? 1 by 4 pi epsilon naught q1 q2 by r square. Sorry, it is
1
medium,
by
na? So epsilon of
4 pi
that
epsilon.
medium we will write.
Epsilon of medium.
Okay, so epsilon r become epsilon of medium by epsilon naught. So permittivity of medium is what? Epsilon naught epsilon r. Okay, so permittivity of medium is what? Permittivity of vacuum into relative permittivity or dielectric constant. That's fine. I remember when we were writing capacitance initially, we wrote epsilon naught A by D. And when we changed the medium, we wrote K epsilon naught A by D. Right? So what was this K epsilon naught? Epsilon naught was the permittivity of the vacuum. And K epsilon naught was what? Permittivity of the medium. Understood? So this is what comes. Epsilon of medium is epsilon naught epsilon r. Understood? The electrostatic force in vacuum to the electrostatic force in medium, that ratio is called as the dielectric constant or relative permittivity. Now we can get that one. Relative permittivity, how much it will come? Mg, if I'm writing, that means whose density I need? Object density, na? Density of particle is sigma. So will I write it? Sigma into volume of object into z divided by mg means sigma v z, and buoyancy force means, what is the buoyancy force acting on the object? Density of liquid into volume submerged, and it's a completely submerged, so object volume will become the submerged volume. Understood?
Rho Vg. Yes.
Understood? So our relative permittivity, how much it is coming? It is coming sigma divided by sigma minus rho. Okay, question will give you the value, like sigma is 2, rho is 1, right? Like that, some values will be given to you so that you can find the exact number as your answer. Understood? But the concept is what? The concept is we should draw the free body diagram to write the equilibrium condition. And once we got the equilibrium condition, then what we can do it, we can apply the and bring the format so that we got the relative permittivity electric. Understand this thing? Please tell me, clear? Now let's take another example. In this example, have you solved the cavity problem? Cavity problem means what? Like initially, it is given like this. A very big sheet is given to us. Okay? A large, thin sheet is given to us. Understood? It has surface charge density something sigma. Okay? What is that? It's a surface charge density is what? Sigma. Okay? From the sheet, what we did, we removed what? A disk part. This portion is what? Removed. Means actually your charge is only in this region. Understood? This is the removed part. Can you see the diagram? Please tell me. Are you getting the diagram? Like it's a
Yes,
thin
sir.
piece of paper. Okay, A4 paper is there or your notebook paper is there, and in that one you have made a hole, a circular hole, so that some part you have removed it. Okay, but the paper is a very large one. Why I'm taking large one? Because we know due to a thin sheet, what is the field comes? It comes sigma by 2 epsilon naught, isn't it? Field due to a very large plate or thin plate is how much? Sigma by 2 epsilon naught. So this is a large thin plate we had. Okay, and from that what we did? We removed a portion of what radius? Let's say r radius. Okay, and now what I want to do, I have a point here. This is the point P, and this point P is how much you want to take it? Let's take it r by 2 distance from the, okay, I need some nice value so that, chalo, let's take it root 3r. Okay, that distance is how much? Root 3r. Now what they are asking in the question, what is the field at the point P? Understood the question? Find the electric field at point P after the disk is removed. After disk is removed. Okay, this is called the cavity concept. Understood? Why it is called cavity concept? See, tell me, if I want to find the field at that point, can I consider that it is a arrangement like this? Tell me what is given in the question and what I am going to solve it. You tell me, is it same or not? Here, if I apply the concept and try to calculate it, then I cannot see any standard shape which acts like this, isn't it? But can I say it is a combination of two standard shape? One standard shape is the infinite sheet, large sheet, right? Let me calculate the field due to this complete sheet at that point P. Okay, let me calculate the field at point P due to complete sheet. They will say, so no, no, sir, this is wrong, isn't it? Because you don't have the complete sheet, isn't it? What is coming in your mind? If I say, no, no, I'm going to calculate field due to complete sheet at that point, they will say, sir, this is wrong. Why it is wrong? Because you are considering a complete sheet. But sir, question gave me it's not a complete sheet. In the complete sheet, some hole is there. Okay. So what I thought, let me calculate due to complete sheet how much will come, and whatever the whole part is there, na, that whole part I will calculate separately at the point P, and whole charge I will consider as what? Something negative. See that if I merge this whole, or if I merge this disk on this sheet, isn't it this much part will be what? Nullified, or it will just act like a cavity only? Please tell me. Please tell.
Yes, sir.
Wherever it was empty part, I consider there also some positive charge. So how to make it empty? So whatever the extra I considered here, exactly same amount of negative charge, let me consider it. Same shape, same density, negative charge, so that when I will merge that thing, it will give me the net effect as the same as my previous question. Understood? So that's why what I am going to do is I am going to calculate the field due to infinite sheet at point P and due to this disk at point P. One will create field away, one will create field towards, and when I will subtract these two field, matlab vectorially actually I am adding, है ना? Like let's say this is the part 1, this is the part 2. So E1 is in this direction and E2 is in this direction. So net field should be E1 plus E2 vector sum. है ना? Net field is a vector sum of E1 vector and E2 vector. But as E1 and E2 vector are in opposite direction, so what I'm doing? I'm just subtracting it. Please tell me, do you understand this concept? So tell me, at
Yes, sir.
point P, what is the net field will come? So can you tell me what is E1? E1 is the field due to infinite sheet. Infinite sheet create how much field? Sigma by 2 epsilon naught, irrespective of the distance. Understood? Minus. Understand? Now, can you tell me what is the field on the axis of a disk? Field on the axis of a disk. Can you tell me what is the field on the axis of a disk? It's a sigma by 2 epsilon naught into on the axis of a disk is what? Sigma by 2 epsilon naught 1 minus cos theta. It is something like this. What is the theta? Theta is this angle. Okay, understood? So please tell me how much it will come. Sigma by 2 epsilon naught 1 minus. What is the cos theta as per my diagram? Just check it. Is it root 3r divided by root 3r square plus r square by 2r? Just check it once. Please tell me, is it the cos theta we have? Root 3r, right? And the radius is r, so that hypotenuse will become under root of root 3r square plus r square. So root 3r by 2r. So this one and this one get cancelled out, right? If you simplify it, what are you getting? Sigma by 2 epsilon naught, right? This minus got subtracted, and what we have? Sigma by 2 epsilon naught into root 3 by 2. Understood? Please tell me.
Yes,
Please tell
sir.
me. Understood this one? So can I take one more example on that, and you should apply the same concept again one more time?
Yes, sir.
So whenever something is removed from a body, always think in such a way that, and this concept is very important one. Why? Because you can apply this thing anywhere. Electric field calculation, electric potential calculation, gravitational field calculation, gravitational potential calculation, center of mass calculation, moment of inertia calculation, magnetic field calculation. Everywhere this concept you can apply it. Understood? तो चलिए, let's take one example and you answer that one. Here what I'm going to do it. I have a sphere. Okay, I have a solid non-conducting sphere, right? Then only now I can give the charge to the complete sphere, isn't it? We have a solid non-conducting sphere. Its charge density is given as rho and its radius is given as what? R. Understood? What is this? It's a solid non-conducting sphere having charge density rho, means charge is distributed like this. Throughout the sphere, the charge is distributed. Now, from that, I am going to make some cavity again. Cavity means what? I am going to remove some portion, something like this. Can you see? This is how I have removed it. So the removed portion will have what radius now? R by 2 will be the radius, isn't it? And originally, what is the radius of this non-conducting sphere? R is there. Now I'm going to give you the 2 points. Okay, I'm going to give you. So can you tell me, if you make a cavity, what will be the charge in this cavity? Nothing, na? There will be no charge in this cavity, na? Once you make the cavity, means once you remove this much portion from the this sphere, there will be no charge in that one. I'm going to give you 2 points. Okay, this is the point number A. Find the net field there. This is the point number B. Find net field there. And this is the point number C. Find a net field there also. Okay. Understand what are the points where you have to calculate the field? There are 3 points given in the question: field at A, field at B, and field at C. Okay. Find net field at A point, B point, C point after removing the cavity. Okay, after removing the cavity, what is the field at these points? Please try to calculate. Which point you are calculating first? Tell me. Calculate that one, then I will ask you one more point. D point. Tell me, are you calculating for point A? First of all, tell me, do you understand the question? The question says we have a uniformly charged. The question says we have a uniformly charged non-conducting solid sphere whose charge density is rho and radius is capital R. From that, a cavity of radius R by 2 is removed, and how it is removed, that arrangement is given in the question diagram. Now the next thing they are asking, that What is the field at point A, field at point B, C, D? These points are given in the question to us. So please tell me, how are we going to calculate that? Actually, calculate at point A first. How you will treat this question? Are you going to treat
Sir, as
a
positive and negative charge.
yes, positive charge of what radius sphere? R radius sphere.
R
And
radius sphere and negative of R by 2.
very good. So we will take this question as if this question consists of two sphere for me now. Right? Earlier it was a sheet. From that a disk is removed. So I consider two objects as what? One as sheet, other as disk. But here from the sphere another sphere is removed. So I will consider this question as two sphere. One positive charge sphere of r radius, other negative charge sphere of what? R by 2 radius. And due to both of them, I will calculate the field at point A. And after that, they will create in the opposite direction because of their charges. So I will subtract them to get the net field. This is the sphere of radius r. I'm just drawing side by side. Plus, there is another sphere of what radius? Of r by 2 radius. Charge of this one I will consider as the positive one, and charge of this smaller one I will consider as negative. Okay. So please tell me now, let's try to find out at different points given. Now, at A. Acha, can you answer me? What is the charge of the bigger sphere? What is the charge of this sphere? If I call this one as Q1. If I call this charge as Q1, can you tell me how much it will come? Will it come density into 4 by 3 pi r cube? And if I call this as the Q2 charge, will I call this is density into 4 by 3 pi r by 2 cube? Please tell me. Please tell. Q1, Q2 value we got it, na? So at point A, what I will write it? So look at the point A. Look at the point A. Where is the point A? Is the point A is on the surface of the bigger sphere, or you can call it a sphere 1 or original sphere. Let me call this as the body 1 and let me call this as the body 2. Tell me, at point A, if I'm calculating, due to bigger sphere, is that the surface point? What is the field at the surface point? What is the field at the surface of a sphere? Is that equal to K Q1 by R square? Please tell me. Is it the field on the surface of a sphere? Minus. For the second sphere, where is the point A? For the second sphere, is the point A is outside the second sphere? Point A is outside the second sphere, na? Okay. The field outside the sphere is how much? K Q2 by distance from center to that point, na? Whenever we calculate the electric field outside a sphere, non-conducting sphere, what do we write it? Kq by distance from center to that point. And is that distance is 3r by 2? Please check the calculation carefully. Please tell me, do you understand this or not? For the point A, for the bigger sphere or the sphere one, the point is on the surface. We applied surface electric field formula. For the smaller sphere, the point is where? outside. The outside formula we have applied. Now we can simplify it. K common, R square common. What is Q1? Q1 is density into 4 by 3 pi R cube minus 3R by 2. Na? So that will come 4 by 9. है ना? 4 by 9. And what is the value of Q2? We have it in the question. So the value of Q2 we have it in the question is rho into 4 by 3 pi R cube by 8. Right? Just take something common which is given in the question. K common, R square common, rho common, 4 by 3 pi R cube common. What I have? 1 minus rho 4 by 3 pi R cube gone. So do we have? And one more simplification, 4, and this will be 2. So do I have 1 minus 1 by 18? Please tell me. So what we have? 17 by 18. 17 by 18, right? R square and R cube. R it will become. So 17 by 18 rho K 4 pi R by 3. We can do further simplification, but please tell me, do you understand? K I can write it as 4 pi epsilon naught. 1 by 4 pi epsilon naught. 4 pi will further get cancelled out. But please tell me, do you understand that point A? How do we get the field? Tell me. Now tell me, at point B, how do we calculate it? So at B, if you are trying to calculate, tell me what is the net field at B will come. So due to bigger sphere, where is the point? Due to bigger sphere, is the point B is still on the surface? And due to a smaller sphere, where is the point B? Is it the surface of the smaller sphere, isn't it? So here, now I will apply for both case surface formula. So K Q1 by R square minus K Q2 by. For the smaller sphere, that surface point is that. Yes, it is. But now I will write the distance from the center of the smaller sphere. Now, that distance will become how much? R by 2 square it will become. Please tell me, can you simplify it now further? Please tell. At point C. At point C, tell me, due to bigger sphere, what is the point? Due to bigger sphere, where is the point? Where is the point C due to bigger sphere? Is it the center of the bigger sphere? मतलब whenever you are writing a field, write it independently. Don't worry about the other sphere. Okay? When you are writing due to bigger sphere, think about bigger sphere only. Charge of bigger sphere. Where is the point? Respect to bigger sphere. Okay? So is the point C is at the center of the bigger sphere? So center, so we know the field is 0, isn't it? Electric field at the center of any sphere is what? 0, isn't it? Rho r by 3 epsilon naught. Field inside a sphere. Is it rho r by 3 epsilon naught? Field inside a non-conducting sphere. What is the field inside a non-conducting sphere? Rho r by 3 epsilon naught. So 0. Due to a smaller sphere, where is the point? The surface point. So I will again use it K Q2 by R by 2 square. Can you tell me D point, what is the field will come? Please tell me, at point D, what is the field will come? So at D, due to bigger sphere, where is the point D? Tell me, due to bigger sphere, is the point D is inside the bigger sphere? Point D is inside the bigger sphere. So how much field will come? Rho, what is the distance? R by 2 divided by 3 epsilon naught minus. Due to a smaller sphere, where is the point D? The center of a smaller sphere, that means 0. Do you understand these four cases of calculating the field whenever some part is removed from one body? Please tell me. Understood?
Yes, sir.
Tell me, clear or not?
Yes,
Or
sir.
is still the confusion
Yes,
there?
sir, clear. No, sir.
Understood? So this is how we will
Yes, sir.
calculate it field whenever a cavity is involved in a question. You can call it cavity, you can call it some portion removed from one object, है ना? And you can do same thing for what? The potential calculation as well. Okay, you can do the same thing for what? The potential calculation as well. Understood? Understood these field calculation question? Actually, let's discuss the one more example here. In the question, what did they give? There is infinite line charge. What kind of charge is given? An infinite line charge is given to us. Okay. The charge density, this is extended up to infinity. This is also extended. Charge density is lambda. Okay. And what happens? There is another charge particle. Okay. Question gave there is a charge particle here. The charge particle is given minus q, and the mass is what? M. And this charge particle is what? It's revolving around this with some velocity v. Okay. So question they are asking, find first thing velocity of the charge particle. Okay, this is the radius of the circular path. Understood? This is like this. A line charge is there, and around this charge particle, what they are doing? A particle is revolving. To find velocity of particle. Okay, understood? They can ask you kinetic energy also. And second thing, time period of revolution. It's a uniform circular motion. Okay, na? The second thing also find out what is the time period of revolution of this particle. Understood? Please tell me how it will come. It's doing what kind of motion? What kind of motion this particle is doing? Can you tell me? What kind of motion particle is doing? Please tell me. Is it a circular motion? Please tell
Yes,
me.
sir.
So if particle does circular motion, what is the requirement? Does it need a force towards the center? Where did it go? Tell me, if a particle does circular motion, does it need a force towards center? Right now? So here in this question, who will be providing that force? Please tell me, who is providing that force? Is the force is provided by the, I think C and D is, you can write it now, C and D field by yourself. Please tell me. That's what happen if many pages are there. Please tell me what is going to be the answer of this one. Charge particle is revolving around this one in a circular path. With what radius? Radius is r, linear charge density lambda. Okay. To find the velocity, what is the particle charge? Minus q, particle mass m. So if you look at this particle, can you say that this particle is experiencing a force towards center? Can you tell me how much is that force? Is that force acting on the charge particle towards center is going to be charge of the particle multiplied by the field. What field this one will create there? Is it the field created by the infinite wire is lambda by 2 pi epsilon naught r? And field will be created in this direction. Check it. Check the direction of field. The field will be created in this direction, away from the wire. And it will what will happen here? That this negative particle will experience force opposite of the field. Understood? So that is the force. Can I say that force must be equal to, it's a circular motion. So in the circular motion, can I say the net force which is acting towards center should be equal to mv square by r? Now simplify it. R and R get cancelled out. What is the velocity of particle are we getting? Are we getting the velocity of particle as q lambda by 2 pi epsilon naught m? Understand the velocity of the particle? And once we know the velocity, can we also get the time period? What is going to be our time period? The time period will come 2 pi r by v will come. And what is the velocity we have just now calculated? The velocity we have calculated q lambda 2 pi epsilon naught m. Please tell me, understood this one? The velocity and time period part. So this is what they ask in the
Yes,
question.
sir.
Okay, find the velocity of the charge particle. And also another thing they ask in the question is the time period of the revolution. Understood? The velocity and time period, these are the two things they asked in the question. Okay, understood? Right? Okay, let's discuss one more example. Are you aware about the simple harmonic motion? Hmm? Please tell me.
Yes, sir. A little
Yes,
bit.
sir.
Charan, Lokesh, tell me.
Yes,
Yes,
sir.
sir.
A little
Okay,
bit.
actually, let's see. There is, okay. Let's say in the question gave there is a ring. Okay. This ring has what? Uniformly distributed charge. This ring has what? Charge Q. Okay. And charge Q is uniformly distributed over the ring. Okay. Gravity free space we are considering. Matlab gravitational force we will not consider. This is the radius R. Okay, tell me, if I keep a charge particle at the center of the ring, what force it will experience? If I keep a charge particle at the center of the ring, what force it is going to experience? Zero, na? Tell me. Because at the center of the ring, there is no electric field. है ना? Field at the center of a ring, electric field at the center of a ring is zero. So if I keep a charge particle at the center of a ring, it will not have any force acting on it, right? This charge particle has charge minus q, mass what? M. There is a small charge particle of charge what? Minus q and mass what? M. Now what we are going to do next? Next thing what we are going to do is, I think we need to delete some pages. Okay, actually, let's see. So in this example, what is given to us? That a ring is given. There is one more example we have written, okay, na? But that page also got deleted. That cavity problem page that got deleted, okay, na? So you can check it, that question you will find it. Okay, let's continue with this example. So in this example, what is given to us? That a ring is given to us. The ring has what charge? Ring has uniformly distributed charge, and the total charge on the ring circumference is distributed, is given as Q. Radius of the ring is what? R. Now, if you keep a charge particle at the center of the ring, right? Then it will experience zero force. I am taking a negative charge particle here. Okay. Now what we did, if I displace this charge particle slightly, along which direction? Along the axial direction. Matlab, this is the ring. Along the axis, we have displaced it by some distance. Can you tell me what will happen? What direction the field will be created? Is the field will be created in this direction by the ring? है ना? And it's a negative charge particle. So can I say negative charge particle will experience the force in this direction? Isn't it this force will again try to bring back the charge particle towards the center? So this charge particle will reach the center, it will not stop, it will reach other side, and can I say it will start doing what? The simple harmonic motion along what? Along the axial direction, okay? So what we have to do it in this question, find time period of what? These questions are what? Slightly mixed with different topic. Okay, na? That's why in the first place we did not discuss, but later when we will go to these chapters, we will discuss these questions. Okay, so find a time period of simple harmonic motion of the particle. Understood? This is our question. So please tell me, I am going to displace. Can I say this is the mean position of the particle? Can I call this center of the ring is also the mean position of the particle? Do you understand meaning of the mean position? Mean position in SHM is that point where the net force acting on the particle is zero. Okay, so when the particle is at the center, it doesn't experience any net force. Na? That's why this center is the mean position. Now what we did, let's say I displace this by x displacement from the mean position. So tell me how much force will be acting. Force acting on the particle will be charge particle multiplied by the field at that point. What is the field at that point? K Q X by R squared plus X squared. On this my distance X. Is this the force acting on the particle, right? At a distance from the center. And if you check here, this force is acting towards mean position. So can I call this as a restoring force also? Please tell me. This force can be also called as particle towards its restoring force. Okay. That is the force acting on the charged particle, right? And in SHM, we have one more concept. In SHM, what is the restoring force? Restoring force acting on a particle is equal to m omega square into x. In SHM, any kind of SHM, the restoring force acting on a particle is always going to be what? Mass of the particle, omega. Omega is called angular frequency, and x is the displacement particle from the mean position. So the particle were displaced by how much? X distance from the mean position. If you look at this expression, you will say, sir, we will omega. Yes, we will not. But if I take, if x is very less compared to r, why so? because SHM happened for only a small displacement, isn't it? If I apply this condition x very less than r, then can you tell me how this expression will be converted? This restoring force expression, how it will get converted? So this restoring force will become what? If x is very less than r, this one will become k capital Q small qx divided by. If x is very small compared to r, can I take r square common? It will become r cube then. 1 plus x squared by r squared whole thing to the power 3 by 2. And after the binomial approximation, can I say that the restoring force become k capital Q small q x by r cube? And what I'm going to do that comparison with? Restoring force in SHM is equal to m omega square x. See that x and x got cancel out. What is the omega we have? Is the omega we have k capital Q small q by m r cube. This is called the angular frequency of SHM. What is this omega called as? Angular frequency of SHM. And what is the time period of SHM? And can I write it? It will come mr cube by k capital Q small q. Please tell, do you understand this question? Understood. So this has been electrostatic mixed with water, mixed with the simple harmonic motion concept. So please tell, do you understand this one? So these are just some of the, you can say, the miscellaneous question of your electrostatics. One question was mixed with circular motion. One question was with simple harmonic motion. Okay. One question with the equilibrium of the body. So please tell me, understood this one, what we discussed now? Please tell me, clear? Right, Lokesh? Please tell me, clear this one?
Yes, sir.
Right. Let's meet it tomorrow morning then, and we'll continue. Okay.